Okay, so just explaining, I've just started the video. I draw my tank and of course where the video's going, what's coming in? Water containing 2 grams of salt per litre flows at the rate of 10 litres per minute. So I've got 10 litres per minute and I've got 2 grams per litre. 2 grams per litre. Grams per litre times, so that's grams per minute. So I've got 20 grams per minute coming in. Okay, done. Now, it's rate in minus rate out. We know that. So it's 20 minus. What is the rate out? Well, we've got to have a look at this. Into the tank that initially contained 50 litres of pure water. That is... What is it? That is just initial condition, isn't it? Yeah. Okay? Who cares? That's initial condition, so that's useless. Flows out at 6 litres per minute. Now, we did say that we want grams per minute, didn't we? Okay, how many grams of salt, given that Q grams of salt, how many grams of salt do we have at any time? Q. Okay. Now it flows out at 6 litres per minute, but how many litres are coming in? So, what's happening? Is it adding? So, 4 litres per minute. But we start with how many litres? 50. Okay, now the problem is you look at this and you go, oh, jeez. But guess what? That is grams and this is just volume, isn't it? Okay, so what are we missing? Times it by what? Litres per minute? Okay, because litres per minute times what? Grams per litre. So what is our litres per minute? Well, we've got to work out litres per minute. What are we going to multiply by? 6. Thank you, 6. So we've got 20 minus 6Q over 50 plus 4T. And of course, I'm going to divide that by 2, which is going to give me, 3Q, 25, 2T. If I got that, beautiful, A. Now, as it turns out, now I'm just going to resume this video now, and we've discussed as a class, how long do you think, if you know your stuff, how long should this question take?
Less than a minute.
So, shout it out.
Less than 30 seconds.
30 seconds to a minute if you know your stuff. Yeah. If you don't, and if you can't read, or if you look at this 50 and think that this 50 means something, then you might spend 7 minutes on that question. I'm going to pause. Now, if you are a robot, which I expect you to be come exam time, not now, this is what I would do, okay? First of all, I've got a differential equation that needs to be solved. So, of course, and instantly I flip. dt dx is equal to negative 1 over 0.15x, okay? Now, what's happening is that this population, if I have a read of the question, the amount of drug X relates to this, the number of hours needed for the amount of X to half. Now, what we want to do is I can actually use integration for this. I know that T is equal to the antiderivative of, I'm going to put negative out the front, 1 over 0.15x dx. And we want to solve that differential equation, but what are the terminals? Let's just make up something. At the start, I'm going to, now of course, you wouldn't have to write this down because in multiple choice you don't need to show working, but at the start we have A. And what do we have at the finish? A on 2. So guess what? If you do that in your calculator, and because you're a robot, and you know how to do that. Now, a lot of you, 3 minutes and you hadn't have done it. And I understand that. Okay, but the level we need to realistically get to is, this is what I do in my calculator. Okay, all right, I've got to solve that differential equation. I start at A and I go to A on 2. So I'm going to go A and I'm going to go A over 2. And I've got a differential equation. I'm going to put a negative out the front. Okay. And is that negative going to work? No. Where's the other negative? This negative is going, oh, jeez. Okay. Oh. All right. Okay. Negative. Oh, can I go Control Z?
Yeah, you can.
There you go. I just learned something today.
But you have to hold.
You have to hold.
Yeah.
Okay. Now, what we're going to do is we're going to put that negative there. Okay. And then I'm going to get my fractions button. And of course, it's easy for you guys to do this on your CAS. And then I'm going to go 1, or not 11, 1 over 0.15x. And that is an x. And what spits out? Now, that's right. And that's such a good point. Okay? And this is what you guys need to do, because you get this answer and then suddenly 15 over 100. Now, I think my calculator, I think this... Oh, sorry, my bad. I'm, really not having a great day. Okay.
Why don't you say if it goes 15 over 100, why can't we just say 15 over 100?
2 periods. One period.
Yeah, one.
Okay. Now, let's have a look at that. What happens? Look at that. Hey! Baby! Oh, baby, how was I supposed to know? Now, 20 log 2... No, I better not. So, shh. So if I pause, now I'm going to resume that. I think we've all agreed that if you know what you're doing and you're that robot and that you've solved that many differential equations, and what was the trick really? Recognising that the population is halving. So this is a differential equation using the fundamental theorem of calculus. The fundamental theorem of calculus. Okay? And a lot of students don't really think about that. And we agreed, 30 to 40 seconds, if you know what you're doing. And that, in all honesty, is highballing it.
Do a lot of people get these right?
Well, if I'm going to pause that, because I'm going to show you that was probably one of the poorest questions. A lot of people would guess that. They would. And you know what? A lot of people would guess after spending 3.5 minutes on it. So what I'm going to do is I'm going to do the old... Okay, I'm just going to resume and look, we did probably waste about 10 minutes looking for that. But I think it's important because, let's face it, how long do we have on average take? Probably about 3 minutes. Now, we have done differential equations, but this is the level you're going to get to. Now, have a look at the stupid way at which they've suggested. Like, this is not an exam 1 where you have to solve by hand. So, you would not waste your time to do that. Now, question 13B was the answer, and Luke, what percentage of students got that right in the state? 65%. But you know what? 65% of the students would have spent, on average, most of them would have spent probably still 3 minutes. Okay? Now, given the fact that I have shown you my way, would you agree that my way is a pretty most time-efficient way of doing it?
Yeah.
Okay? So I don't want you to see these MAV solutions. These MAV solutions are written by they're academics, but these are the guys that are in lecture theatres who speak to you for 2 hours and they lose the room after about 7 minutes. Because I'm telling you now, they don't have your best interest at heart. Okay, your best interest is do it in as quickly as possible. You have a CAS calculator, do it that way. So I hope that you've learnt a little bit today about that. Now, how the hell do I get this off? I wouldn't have a clue. But where's Alt Tab? I can't even Alt Tab. Swipe from the left. Okay. Thank you. All right. Now we're still going. So I'm going to... I'm going to pause this and we're going to go through another problem. And it's this one. Now, this is exam 2, ladies and gentlemen, and I can guarantee you that this was a really poorly answered question. Can I get you to just stop there, have a think, have a look, have a go at this question, please? Shh. Okay, now this question is an exam 2 question. And I did say to you that differential equations, setting them up, understanding them, understanding that some even might be implicit differentiation, might be used in this to verify. Now, my best student from last year, Sarah Webster, okay, did extremely well. I won't, and she tutors a number of you. She struggled with this question when she first looked at it, okay? So we all would struggle, I'm guessing, except for Luke. Hey, Luke, looking at this, what do you think?
I'm thinking get n as a subject.
Yep.
And then use the calculator to solve the dndt.
No, you can't.
No?
Because it says verify. Now, the thing is, what I'm saying is, you need to show your steps. Now, that doesn't mean you have to show literally every step, but because you have, it says verify, I'm going to show you and explain to just quickly. First of all, I've got log e to the base n, right? So what I'm going to do for this case is I'm going to do this. I've got log e to the base n is equal to, now they've given us this, okay? Now what I'm going to do is I'm going to derive with respect to t both sides, okay? Now the problem is, of course, this is in terms of n, and the right-hand side is going to be quite easy, isn't it? Okay, and I'll get to my reasons why in a moment. Now, if I derive the left-hand side with respect to t, what does that give you? Let's pretend that t is x, and let's pretend that n is y. Okay? What is the derivative with respect to x of log e of y?
1 on y.
1 on y, y dash, isn't it? So, but we got to use the notation that we've been given. So that's going to be, isn't that going to be dn dt times 1 on n? Are you okay with that?
Yeah.
Okay, now that is a tricky concept to understand. Then I've got to have, that's 1.2 e to the negative 0.4t. You follow me so far?
Yep.
Okay, now what we've got to do then is I'm going to, now be careful because I've got an expression which involves that. But now we need to now verify this. So what we're going to say is that dn dt, which I've shown, not because I've done in my calculator, is equal to n times 1.2 e to the negative 0.4t. Are you okay with that?
Yeah.
Okay. Now what I'm going to do is therefore 1 over n times n 1.2 e to the minus 0.4t plus, now have a look at this. Log e to the n is given here, but haven't we been given an expression for log e to the n? What's this? What's that? So what I'm going to say is plus, and now of course you wouldn't do this, you wouldn't split it over two lines, but it's hard to do it on this. 0.4 log e to the n, well log e to the n, I'm going to replace that with that because it's the question's told me that. Okay, now let's see what that equals. N over n is 1, that's 1.2, and by the way, there was a negative 2.4 there. Okay, all we're doing is verifying. So it's 1.2 e to the minus 0.4t plus 2.4 minus 1.2 e to the negative 0.4t minus 2.4 is equal to 0. What do we do? As required. Okay? Now, that looked easy. I think I made it look easy, but it's not. Because if you didn't think about the variables, think about the variables that we've been given. But I'd like you to think about this. It's like, just pretend that that was an x and that was a y, and then maybe sort of think about it from that, because you really needed to use implicit differentiation. There are other ways of doing it, but in my opinion, the easiest way was doing it that way. And I'm always going to show you the easiest way. I thank you for your attention today. I'm going to stop that video. We're going to continue on with this and do another part next week. Okay? Good luck and